Welcome to Irrational Science. Why are we rational? Well, because most everybody out there is not. That's why we do rational science here, rational physics. Today we have a couple ladies that we're going to be talking about who do a lot of irrational physics. We're going to discuss why they do irrationality only. In other words, they do religion. That's what they do. Here are these two ladies. We're going to present them. Fine ladies here. One is Becky Smethurst, and the other one is Dianna Cowern. And the first one, the one on the left, she is from Oxford. She's an astromathematician. She does all kinds of magic in the astro world, in the cosmic world. She's a junior research fellow at a church, Christ Church, Oxford, Anglican Church. I guess they turned those into laboratories now. You can work in there to do some so-called astronomy. And she's a mathematics communicator on YouTube, and her moniker is Dr. Becky. Yeah, she's got in order to be a junior research fellow, you must have a PhD, or apparently it's generally required. Okay. The other lady, Dianna Cowern, she has a BS in mathematics from MIT and decided to go into science communication also. She got a YouTube channel known as the Physics Girl, and I think recently she ended a 5-year partnership with PBS. She decided to go all on her own because she's popular enough that she doesn't need PBS, or maybe PBS fired her. I don't know the details. Anyways, why do these ladies do irrationality? Why do they do religion? Well, today we're going to discuss how they analyze Mr. Einstein and some of the little things that happen in general relativity, some of the explanations we get from the establishment, okay? And by the way, I want to mention just the fact that, a person like this lady, Becky, let me put her up here again. She does the fact that she's got a doctor's degree, PhD degree. It's really not important because it depends on what you studied. Here we have a famous fellow. His name is William Lane Craig, and he wrote a book on the the cosmological argument that he's got for the existence of God, with an emphasis on the alleged metaphysical impossibility of an infinite regress of past events. And his doctoral thesis, he's a doctor, right? PhD, the historical argument for the resurrection of Jesus during the deist controversy. How's that for a doctor's degree? So yeah, a lot of these people get doctor's degree, and I'm wondering really how much they're worth. And in fact, Dr. Becky is no different. She got a degree in mathematics. Whether that has any value at all, I don't know. She did spend time, but like Mr. John Baez says, in his crackpot index, nobody cares how long you spent trying to figure out something. It's irrelevant. It's whether you have that moment in which you see, how the universe works. Otherwise, all you did was warm a desk or a seat, at the in college. Okay, so first thing that Becky does in her presentation, I'm going to go with her first, is pay homage to Einstein. You absolutely must pay homage to Einstein if you're going to do communication, science communication, physics communication. Otherwise, people will be turned off, because you really have to respect the gods of general relativity. Okay, and here, put this over here. Here she is. She says the following about Mr. Einstein to begin with her. One of the things that physicists find ourselves saying all the time is that Einstein was right. Now, how's that for a starting point? You got to say that Einstein was right. You can't say that Einstein was wrong, because otherwise you got a big problem with a lot of people, okay? His theory of general relativity is the best description we have for how gravity works. Well, she already starts with a contradiction, okay? Theory is an explanation. She's talking about the best description. So how can we have a theory that is a description and confuse that, with the fact. Let me get something here, right here. How can we have a description and call that a theory? If someone asks you how something happened, you're not going to say, well, it happened 1 + 1 = 2. What do you mean 1 + 1 = 2? Is that your theory? Yeah, that's my theory. No, that's not a theory. A theory is an explanation of something. You got to explain how something happened, especially in physics. And so we have a problem here because she talks about theory of general relativity, and she says it's the best description. So obviously she did not learn that in science school, wherever she studied. I guess she studied at that Oxford monastery or whatever. So yeah. Every test we put it through, it passes with flying colors. We don't test theories in science, in physics, because testing just means you want to prove to yourself that you're right, or you want to prove to someone else that you're right. And in science, we don't prove, and therefore we do not present evidence to convince, persuade, convert, and recruit people. They do that in Sunday school, maybe at Oxford Christ Church, maybe that's where they do it, but not in science. We don't do that in science. So she says, so does that mean that we can just pat ourselves on the back because the job's done? You got to leave a little room for the new generations, because if Einstein did it all right and figured it all out, what's there for anybody else to do? We're done with physics. So they have to leave that door open and say, well, we don't know everything. Oh, we don't know everything. I thought we did. I thought Einstein was right and proven right, and everything's peachy with Einstein. And here they say, well, he was correct. He was right. He was true, right? But he's not quite there yet, So that's that little bit that they have job security with, right? And it says, no, we are still testing gravity. We're coming up with different theories of gravity. So what is a theory? Let's find out what a theory is, because apparently this lady is very confused in what a theory is. Okay, let's find out what a theory is. Theory, it says in science, this is not from me, by the way, in science, an explanation or model that covers a substantial group of occurrences in nature. And I would put a period there, but they continue because these are mathematical notions that have been introduced into science, which have no business in science. Says, has been confirmed by a substantial number of experiments and observations. By whom? By the Vatican? By the Dalai Lama? Who confirmed this? Here we're talking about confirmation. Confirmation is an issue of belief, not an issue that concerns science. In science, we explain a mechanism, we show it on the screen objectively, and once we understand it, that's it. Then you can believe in it or not if you want. If you want evidence, you can go and get evidence, to run your own experiment, try to convince yourself or convince others. That part is religion. Science ends at explanation of an objective mechanism. That's it. Once you visualize the mechanism, once you see it, you're done. That's the science part. Now the rest is religion, belief, opinion. Okay? A theory is more general and better verified than a hypothesis. Absolutely not. Okay, that's only in the religion of mathematics that they do that, where they verify and they say, well, this is more people voted for this than for that other one. So that one's still not a theory. This one's a theory. And when everybody raises their hand, we call it proof. It's been verified to exhaustion. Everybody believes in it. What? Believes. Until a new one comes around and says, well, you were all wrong. Maybe we all believed in the flat earth at some point in time in the past, but then slowly we got away from that. What was truth then stopped being truth later on, which again, it means all we did was change opinions. It's not that the flat earth was proven and it was guaranteed. It was that at the time people believed that it was flat, and they had all kinds of evidence and proof and experiments to show that the earth was flat. So no, we don't do experiments, we don't present evidence. But this is what this lady was taught. And she just repeats it, just regurgitates it, like a poem. Okay? And no, hypothesis is not what it follows here. I put that in there because it says verified, better verified than a hypothesis. Hypothesis, a proposition or set of propositions set forth as an explanation. No, a hypothesis is not an explanation for the occurrence of some specified group of phenomena, either asserted merely as a provisional conjecture to guide investigation, working hypothesis, or accepted as highly probable in the light of established facts. None of that has anything to do with a hypothesis. In fact, you'll find many synonyms of hypothesis, among them assumption, prediction, asking a question. There's all these synonyms for hypothesis, and people don't really know what a hypothesis is because it's got like 10 different notions of what a hypothesis is. A hypothesis is an assumption. And what does it include for rational science? It includes the objects you're going to introduce for physics, the ones you're going to put on the screen, includes the definitions, and of course it includes the initial scene. We need to know where you started, to do your theory, okay? And your theory had better follow from the hypothesis. Okay, this lady continues. She begins with Einstein's equation. She does a very quick analysis that really glosses over a lot of stuff, but in a way it's not so important. I'll show you why. She says what the tensors do is mathematically describe how space is curved by an object with mass. That's all she says, and essentially that's all that you really need to know about this entire equation, which is Einstein's equation, okay? The left-hand side of the equation of the equal sign, okay, it talks about the curvature of space-time. The one on the right talks about mass and energy. And if we follow Mr. John Wheeler, he tells us that mass tells space-time how to curve and space-time tells mass how to move. And that's essentially what this equation does. Do you see an explanation of anything in there? No, obviously you'll never find an explanation in all of mathematical physics except the irrational ones, right? But I mean, rational explanations, you won't find them there because all of their stuff is just math, equations. Equations have nothing to do with physics. Physics is physics and math is math, and never the twain shall meet, okay? So one thing is an equation that says, well, space is curved, and mass tells space how to curve, and then once space is curved, which is like a circular argument, once space is curved, it tells mass how to move. Great. And that's essentially what Einstein's equation is all about, okay? So here we'll go with a simpler equation for those of you who are familiar with it, okay? And this is, not me, gotta pull this other guy out. Let me get him. Here's Newton's equation, and what he said, mass divided by distance squared. And that gives you an idea why he said the Earth doesn't leave the solar system. Okay, but he says hypothesis non fingo. I frame no hypothesis. Why, he was a particle man, particle man. He was a particle man, and he could not explain this magic trick with particles. Okay, and that's essentially what caused his downfall at the turn of the 20th century, when all these guys like Lorentz and Einstein and Minkowski, they came in there and they said, oh, look, we have a better physical interpretation. And that physical interpretation was what? Warped space. Warped space-time, sorry. Didn't mean to leave that time factor out. Okay, so he had no hypothesis. He was honest. He said, look, I don't know how it works, but all I can do is describe it mathematically. And if they would have stopped there, great, we have no problem with that. I have no problem with Newton's equation, and I don't have a problem with him saying, look, we don't understand gravity. We don't know how it works. All we can do is describe it mathematically. But Einstein purported to do something else. He purported to explain the mechanism, okay? And of course, after that, they just say, oh, by the way, we don't understand it, or we can't visualize it, which means the same thing. You know, they can't understand it because they can't make a movie of it and put it on the screen for you. They can do a two-dimensional movie and they say, well, it's an analogy. You got to think of, you know, you got to extrapolate flat land to solid land to the fourth dimension, to the tesseract land or whatever, right? You know, four-dimensional world out there that they claim exists. Okay, she continues and she tries to explain a little more about what these tensors are. Okay, so she goes into a little bit of that. She says, with tensors, we appreciate the full four dimensions of space-time. Great. There's three dimensions of space. I thought objects had dimensions. Well, in relativity, they made space into an object and they think it's a thing. And so they talk about the three dimensions of space. And that comes all the way from geometry, all the way from the days of the Greeks. So they always called solids, they call it space or 3D space or whatever. No, not in science, not in physics. In physics, space is nothing, that which has no shape. And an object, that which is 3D in general, right? An object is that which has shape. So there we have it. We have space and something. Nothing and something. They're antonyms. We can use them consistently in any discussion. What are the three dimensions of space according to this lady? What did she learn by memory in school? What does she regurgitate? She says, the three dimensions of space, forward and back, left and right, up and down. I didn't know there was a dimension called forward and back. Have you ever heard of that? I don't know of a dimension known as left and right or up and down. No, those are not dimensions. First of all, those are known as vectors in physics because vectors represent motion. Dimensions do not have anything to do whatsoever with motion. She didn't learn these basic things in college or in high school. I don't know where she learned this stuff. No, there are no such things as no dimensions as left and right and front and back and whatever nonsense that is. Okay, so let's see if we can educate her on what a dimension is and why mathematics does not have dimensions, coordinates, or vectors. They don't use those things. Okay, they have something else. Okay, what they have are number lines, which they confuse with dimensions, coordinates, and vectors. Okay, the dimensions of physics are the one on the left there, and you see its orientation, length, width, and height. Coordinates have to do with location and not with structure or orientation. It has to do with the location of something in space, you could say, okay? And then vectors have to do with the three possible motions an object can move in three mutually perpendicular dimensions from a given location. Math is something totally different. Math only has number lines, and what they do is they call these vectors, they call them coordinates, they call them dimensions, when all they are is number lines. Mathematicians don't care about dimensions, qualitative dimensions, coordinates, or vectors. What they care about is numbers. They care about magnitudes, and those are all number lines. What a number line has is has magnitude, but it has no direction. And people see that little arrow at the end of the line and say, oh, there's direction. No. You can put the number line in any direction you want because a number line has no direction. Number line just says that numbers increase or decrease or whatever. Number line has nothing to do with physics, with the physical notions of dimensions, coordinates, or vectors. Okay? So every time a mathematician pronounces the word dimension, coordinate, or vector, he's going to talk about a number line. Okay? And what they've done in order to, sneak it into physics, they gave magnitudes direction. So now we have a series of numbers that have direction as well. The direction part belongs to physics. The numbers, the number line, that belongs to math. And never the twain shall meet because one is qualitative, the other one is quantitative. So that's how they got messed up with dimensions, coordinates, and vectors. That's how they mixed up the number lines with that. Okay, that's how they got into, they got their foot into physics with that. Okay, because now they're going to talk about dimensions, coordinates, or vectors when they have no business talking about that in the context of number lines. Okay. Then she goes in there and says, well, general relativity is right. It's correct, because in math phys, what is important to them is whether you're correct or not, whether your opinion is right. They don't care about objective explanations that you can see on the screen. If I want to know how the box was pulled by a pulley, well, I make a movie of it. And I say, look, this is how the box went up. I pulled on a rope that was wound around a pulley, and I tugged on that, and that's how the box went up. And you watch it, you see it, and you say, okay, I understand it. Because we all, 8 billion people on Earth, unless maybe you're blind, watch that and say, okay, I understand what happened. The box went up because I pulled on the rope that went through a pulley. That's how physics works. That's not how these people work. They talk about, did I prove it to you? Okay, here's the equation. Let me prove it to you through an equation. What's an equation? A description. It's not a mechanism. Okay, they can't have a theory in mathematics because mathematics does not deal with explanations, and theories are explanations only. Okay, so this lady goes in there again. She has to pay a little homage to good old Einstein. She says, everywhere and every way we've been able to test general relativity, its predictions, astrology, okay, predictions have been right. They're not wrong. They can't be wrong, because if they're wrong, we got a lot of people unemployed up there, the high places. No, they have to always be right. And of course, for that, they had to introduce censorship and forbid people to attack the theory of general relativity, the explanation, the physical interpretation of general relativity on the basis of irrationality. They say, well, we know it's irrational, but we don't care about that because that's a physical interpretation, and we don't do that here in mathematical physics. That's on the other side of campus. They do that over there in philosophy of science or philosophy of physics or some ontology course or whatever. No, here what we do is equations, but then why did they try to give a physical interpretation to it? Because otherwise mathematics would be worthless garbage. We wouldn't care about math if it had nothing to do with physics. So they had to incorporate math into physics and create this thing called mathematical physics, which we call mathemagics, because all the explanations, all 100% of the explanations of mathematical physics related to invisible mechanisms, invisible agents, invisible intangible agents like gravity, like magnetism, and so on. They have no explanation, no rational explanation for any of those, okay? So that's why they have to invent, principles like, uncertainty and complementarity and so on. Or what's the other one? The equivalence of Einstein's equivalence, which I discussed in the past. Okay, so everything from planet orbits to pulsars to black holes to gravitational wave, it's all evidence. Evidence, proof. I'm going to convince you. I'm going to persuade, recruit you. Evidence in favor of Einstein's theory of general relativity. Okay, says those equations that he came up with are thought to govern everything from the expansion of the universe to the behavior of black holes to how gravitational waves move through space to the formation of every single structure in the universe, from the smallest planet to the biggest galaxy to the biggest clusters of galaxies. Okay, so what is that gravitational waves? What the hell is that? How can they move through space? If here you have it, okay? If gravitational, well, a wave of any kind, if space is the black stuff, I don't know what the particles are, but the particles, they say, are the space. They say that space is made of particles, okay? And I don't know what gives shape to each one of their particles if the particles are space and space has particles. So we have a little problem there. But then what is the wave? Well, the wave is not a separate entity that moves through space like she says there. No, it can't be. If that wave came over here, it's the vibration of the ether, which is all those particles which make up space, which is space itself. So it's space itself which is vibrating. because like when they found these alleged two black holes that collided, and from there they came all they had all these waves comes towards us, which they claimed to measure, and they got a Nobel Prize for that. Okay, what happened? Well, the two things allegedly collided. What did they vibrate? What was it that was waving all the way to Earth? Was it the particles? Was it the space itself? What was vibrating? We need to identify that thingy. And see, they don't do that. So she talks about waves going through space, like if space were something else. No, it's the vibration of space itself according to general relativity. So it's space which is vibrating. So you can't talk about the wave going through space. You can talk about space vibrating or oscillating or whatever. So that has to be clarified. Of course, they can't make a movie of what they're saying because they can't. Because as soon as they put what I just put up there, let me put that one more time there. Okay, if they're going to put this thing here, right? Well, then you have to identify what you're staring at. What are you staring at? Are you staring at the ether? Are you staring at space? Are you staring at particles? Are you staring at a wave? What is that? What do you mean the wave went through space? So that's the issue. They can't illustrate this. And of course, none of mathematical physics can be illustrated, which means it's irrational because a theory of physics, a mechanism of physics, has to be illustratable. If you can't illustrate it, it doesn't belong to physics. Period. We're done. Okay? It's just, that's how simple it is. Physics is only about explaining mechanisms. And the rest is all mere opinion, as Mr. Democritus would say, okay? Okay, this lady continues. She says, but what about the areas where we've not been able to test general relativity? Okay, yeah. For example, around bigger and more energetic objects. And then she talks about the smallest one. She says the entire universe, perhaps, or on the opposite scale, the tiniest objects in the universe, such as particles, the quantum level. And there you have their famous planetary atom, which is the one they still use to do what? Electricity, quantum jumping, ionization. They did all with this monster. Okay? And of course, they cannot explain what holds the bead to the nucleus. Why doesn't the bead, the blue electron bead there, why doesn't it spontaneously fly away? That's what they cannot explain. What holds it to the proton or to the nucleus to begin with? And of course, then they have those little gluons there that hold the quarks together. And the red stuff you can think of as a sea of gluons. And the question is, how do particles hold the quarks together? I mean, the gluons are supposedly particles, discrete particles. We don't know what surrounds them because you have to give shape to each gluon, but that's one issue. The other issue is that, okay, I'll give you all the particles you got. You got the whole sandbox. Show me how in a sandbox, the balloon attracts the basketball on the other side of the sandbox. Show me the mechanism. How do you do it with particles? Okay, and yeah, what they do is they say, well, we're going to try to introduce general relativity into the particle world, and that's known today as string theory. It's string theory is trying to merge quantum mechanics with general relativity. What they say is quantization of space-time. Look at the little points. In fact, nothing's really changed because space-time has always said that space-time itself is made of points. It's made of events. What's an event? A point in space-time. It's a, circular argument. Okay? What constructs space-time is a bunch of events, and each event is a point in space-time. And what is a point in space-time? Well, it's one that you locate with 4 coordinates or really 4 number lines, right? And you locate it with 4 number lines. And that's gives you 4 coordinates, and that gives you the unimaginable space-time that they're talking about. Always unimaginable. Everything in mathematical physics is unimaginable. They've given up on that, like Mr. Feynman said. Okay. And so she continues, if general relativity is correct, it's got to be correct, or right? It can't be false ever. Cannot be allowed to fail. Too big to fail. Then it predicts another prediction. We're gonna Crystal ball. We're going to do some predictions here. That 96% of the universe is dark and doesn't interact with light. Okay, it's dark. Yeah, I know. I look at the sky, I see that it's all dark. And in between the darkness, you see some little lights. Is it 96%? Well, maybe, yeah. I don't know. I haven't counted the percentages. But yeah, there's more darkness out there than there is light. So what? Okay, so what's the point here? Okay, it says it predicts, another prediction, okay, that dark energy. Oh, energy. Energy is the same energy that Mr. Feynman says, us mathematicians, we have no idea what energy is. Said it in the Feynman lectures, okay? So he said they don't know what energy is, but it's all made of energy out there, 70% of the universe, and we don't know what it is. Of course you don't know what it is, because energy is not a what. You can say the universe is made of, rocks or horses. That wouldn't make sense, because more sense than this, at least, because you can imagine a bunch of horses, making the whole universe. Okay, fine. But when you say it's made out of energy, it's like saying it's made out of love. What do you mean it's made out of love? What sense does that make? And then she said, well, we don't know what love is. Yeah, I know, because it's not a what. Love is a concept. It's a dynamic concept, and so is energy. So you can't talk about energy, because energy is a mathematical concept that they introduce in an equation. And they can't put a horse in an equation. They can't put a rock in an equation, or a tree. They have to put the mass of the horse or the length of the tree or some number in there. And that's what they do with energy, because energy is not a what. Energy is a concept. She never learned this in however many years she studied to get her PhD. Okay? It is this mysterious force or energy. Yeah, it's got to be mysterious, okay, because you can't imagine it. That's acting against gravity to cause the expansion of the universe to speed up. Well, yeah, universe is a concept, so concepts don't expand, okay? So to say that universe expands is like saying intelligence expands. What sense does that make? Okay, and universe is a concept. There's no physical object, standalone object called the universe. Okay, you can talk about the matter in the universe. That's one component. The other component is known as space, and space is nothing. So we have a concept. We have a relationship between an object and a concept, which we treat momentarily as an object. What is a concept? A word that includes two objects, or words treated as objects, in this case space. Universe treats space as if it were a physical object. They say here we have matter and here we have space. It's a concept. So you can't say the universe expands. You got to say either space expands if you're going to treat space as an object, or you're going to say matter in the universe is exploding. Okay, there's this explosion, all the matter is separating. We have a hand grenade here, all the debris is spreading out. So these are two different notions. Okay? But they just say, oh, the universe is expanding. They fixed it with that. Okay. Okay, then the other chunk of the universe is dark matter. Ooh, dark matter. It's always dark. Racism. That's what I call it, racism. Okay? There's so much evidence for dark matter. It's all just gravitational in nature. That is, we don't see it. Okay? We have evidence, but we don't see it. It's like the air. I have evidence of air because I move my hand. At least I can touch it. Here you can't see it or touch it. Okay? Keep that in mind. Okay? We don't see it with our eyes necessarily, but we see its influence due to gravity. They see these things indirectly. They say, this is what we do see, and we call what caused it dark matter or dark energy or dark people. I don't know, whatever. They invent these concepts and they say that's what's moving it. Well, no, the way it works in science and physics, you got to identify that object. You got to show me a picture of it first. Then you can tell me that this is what moves that one. It's not an issue of evidence. It's an issue of please draw it so that we can see the mechanism. What the hell are you talking about? What is this dark matter? She says we don't know what it is. She's got to tell me what it is. Especially if she's going to say that there's a lot of evidence for its existence. Then she's got to put it on the board. This is like saying, God is what moves everything. Okay, can you draw God? Oh, I don't know what he looks like because, I've never seen him. I've never had contact with God. Well, no, draw God, and then then you can show me with his hands how he pushes things around. Then I can understand the mechanism. But if you say, well, God is this concept, this unimaginable being, all you're doing is putting it beyond reason. And that's what these people do with all this. Okay? They're talking about the influence, the indirect impact that whatever's out there has on the visible things. And they infer, they surmise that there's something out there, and they call that dark matter. But see, when we come to the conference and give the presentation, the dissertation, you got to stand up there with a microphone and say, okay, let me tell you now what dark matter is, what I propose it is. It's this, and you point to it. And people are going to see something on the screen and say, oh, I see what dark energy is, or dark matter, or whatever, dark whatever. It's all dark. Now you can see the mechanism. You see, okay, I see that this is pushing that, so I can see how the universe is expanding or whatever. But until you identify the physical object, what the hell are you talking about? This is the problem. These people do not identify it because they don't know what they're talking about. Okay, so what is this dark thingy that they found? Well, this is just a quick version, the Bill Gates version. I don't call it dark matter, I call it dark kilograms. Okay, dark kilograms. Why? Because they're light there, because all the kilograms, I had to put them as a contrast against the black space in the background. Okay, yeah, what they found out is that galaxies don't rotate like the solar system. Solar system, Pluto takes a long time to go around the sun, 248 years, Earth years, whereas, what is it? Mercury takes, 88 days? So this guy goes real fast around the sun, Mercury, and Pluto takes a long time to go around. That's not what happens here. Here, the stars on the outer side of a galaxy move faster, or at least as fast as the ones on the inside. And that violates Newton, it violates Einstein, and another guy named Mond, who I'll talk about in a second here. It violates everybody's equation. So they had to cheat. And they say, well, the only thing that could be causing it is gravity. That's the only thing they could think of, gravity. And if it's gravity, okay, fine. What they had to do is sprinkle kilograms on the outside of the galaxy. And they say, with this ad hoc invention, right, we can explain how a galaxy sticks together and more or less turns like, a carousel, all at the same time, more or less. Some stars on the outside go faster, fine. But I mean, the galaxy rotates, as if it were a single disk, as if it were all interconnected. Like in the rope model. The rope model, all atoms are interconnected, all stars are physically interconnected. That's why a galaxy rotates as a single disk. There's got to be a physical connection between stars, between atoms, in order for this to happen. Instead of that, they said, no, it's got to be it's got to be some mass that's on the outside. Okay, it's got to be some mass that's on the outside that's holding it all together. Okay? I just got a call on from my wife, so I better behave now. Okay, the wife's on watching probably. Okay. Let me write to her real quick. Okay. Okay, let me continue here. Okay, next topic. This lady continues, and she says the following. She says, so all those things, dark energy, dark matter, really do raise the question of whether general relativity that has served us so well so far on all scales we've been able to test it on is maybe not the full picture, because there are things that they claim that maybe general relativity, maybe Einstein's equation does not answer completely, okay, especially at the atomic level and maybe at the grand level beyond what we can see. In other words, at the universal level. the big and the small, the extremes. Okay, it's not that Einstein was wrong. You have to always uh, pay homage to Einstein. Einstein was not wrong. You can't say that Einstein was wrong. Okay, because otherwise, they're going to execute you. Just like Newton wasn't wrong. Newton wasn't wrong either. None of them were wrong. None of them ever can be wrong, because a lot of people would lose their jobs if these guys were wrong. Okay? It's just that in the scales that we're looking at, it just maybe needs modifying slightly. Okay? So now what the new generations will be working on for the next gazillion years will be on modifying what little Einstein left for them. Just the modifications, just tweaking that equation back and forth until, kingdom come. That's what they do now. That's how they make their bucks. Okay? She does propose, says, well, there's a lot of alternative theories that people are working on. I don't want to call them alternative, because alternative theories are used to, demean, to laugh at people like the electric universe, which I agree with them. I would laugh at the electric universe as well, or the etherists of John Chappell's Society, and Ken Wheeler and all these other guys who come up with all these weird theories. And so they laugh at them and they call those alternative theories. So these are not really alternative theories. They're like branches from the mainstream. Okay, but branches which bother the mainstream. But they say, see, we have all these theories that are challenging us, but we've always been able to reject them because they have no place under mainstream. But it was good that they came to challenge us. Okay, so that's the idea. They want to say that there's a scientific debate. No, there isn't. No scientific debate, because it's pure censorship. Okay, and one of them is MOND, M-O-N-D, okay, modified Newtonian dynamics. And another one is the possibility, right? Add a new gravitational field to general relativity, like a fifth force. Okay, they have these four horses of the apocalypse in mathematical physics in general. They have the electromagnetic horse, the gravitational horse. They have the gluon horse, and they have the weak horse. They're all the four horses, as I call them, of the apocalypse. And they say there could be a fifth horse. Okay, that's the one that hopefully wins the race. Okay, and so they could modify the equation by putting this little new force that could be out there. It's just a modification of Einstein's equation. And another one is to add extra dimensions, which is what string theory essentially does. Okay, but she begins to reject some of these. She says this one, for example, MOND, okay, proposed by this fellow, Mordechai Milgram, and I'm just going to go real quickly over it. You see those A's there? It's Newton's equation, and it's multiplied by this factor, and it's got the A on top, A on the bottom. But this guy proposes that there's a different acceleration for things that could replace the dark matter out there, and that could cause the same effect. Okay, this is what he proposed, and what happened to him? Well, he had no success. Okay, he had no success, and this was why. Okay, or this is what she says at least, says that MOND predicts that gravitational waves should travel at different speeds than the speed of light. But in 2017, we detected the exact same object at the exact same time, a burst of light and gravitational waves, suggesting that they travel at the same speed. And that was a huge blow for that theory. So that was the end of Le Monde. Okay, that was the end of him. Okay, or at least apparently this is what the establishment considers, that MOND is dead, and I'm sure there's a lot of people still doing MOND out there and who believe in that stuff. Okay, and here's the other one, the string theory, and her opinion on this is gravity is governed by the exchange of particles. Actually, it's a string called the graviton. Okay, that's under string theory. Okay, to work, string theory needs 10 dimensions, but not the 4 of space and time that we're familiar with. Well, I don't know if she's familiar with it. I only recognize 3 dimensions, length, width, and height. I don't know any other dimension other than that. Time is a number line, not a dimension. And in fact, that's all that mathematical physics has, number lines. And then she says, the issue with string theory is that it doesn't give you any explanation for dark energy. It can reduce any, it can't reduce any sort of repulsive force that could explain the accelerated expansion in the universe. Okay. Well, I would reject it on a different basis, and that's that if string theory says that all these particles are just vibrations of strings, one-dimensional strings, another nonsense that doesn't exist out there, you know, but these people say there's one-dimensional strings. They vibrate and they create these particles. Okay, fine. That's their argument. Fine. Now you got the particle. Now explain how the particles pull, how the particles cause attraction. Okay, that's all you got to explain. Just explain the mechanism. In fact, don't explain it. Keep your mouth shut. Just make a movie of it so that I can watch it and I can see the mechanism with my own eyes. Then I'll understand it for sure. Okay, so all you got to do is explain, you know, how particles produce accelerated or acceleration, gravitational acceleration in the direction of another object. That's what you got to explain. Very simple. Okay, so once they explain the mechanism, we'll all understand it. And again, all they have to do is make the movie. You can't make a movie of it. You don't have a theory of physics. You have a theory of mathematics. Okay, and how does she end? Well, if she rejects all these other competitors within mathematical physics, she says, so our best theory for how the universe works is still one where general relativity is the best description. Theory is a description we have for gravity. And of course, Einstein sticks his tongue at all of us. But if you accept Einstein's theory of general relativity, then you have to accept that dark matter and dark energy are things. So now we have these concepts, somehow they morphed into things. Okay. Okay, that's good old Becky. Okay, let's go with other lady now. What does she talk about? Well, she talks about just about everything she did. Becky didn't talk about, which is black holes. Okay, so here we have our dear friend Dianna. Okay, and she says she also starts with Einstein's equation. Okay, she says, according to Einstein's field equation, the gravity of an object is proportional to its density. And there you have it in the equation. So if an object is dense enough, then nothing that gets too close can ever escape, no matter what. Nothing, not even light, can escape from an ultra-dense object. We call that object a black hole. No, absolutely not. Okay, that's not what a black hole is. Okay, and it's not an object that's dense enough. That's not the real definition. Let's find out what the definition of this is. Okay, so that Dianna here learns it as well. Okay, here we have Mr. Stephen Hawking. I mean, how much more authority do you want than that? I mean, you're going to believe on authority. Here you have it. And this is what he says in his book. He says, Chandrasekhar calculated that, he was a Nobel Prize, by the way, Chandrasekhar, Indian fella, okay, calculated that a cold star of more than about 1.5 times the mass of the sun would not be able to support itself against its own gravity. Would it collapse to infinite density? This is all in his book, okay? Eddington was shocked by that implication and he refused to believe Chandrasekhar's result. Eddington thought it was simply not possible that a star could collapse to a point. Einstein himself wrote a paper in which he claimed that stars would not shrink to zero size. Okay, that was the issue. And he continues, he says, however, he was awarded the Nobel Prize in 1983 for his early work on the limiting mass of cold stars. Chandrasekhar had shown that the exclusion principle could not halt the collapse of a star more massive than the Chandrasekhar limit. So that's about as much authority as you can get, right? I mean, all these people believe in authority. There you have it, okay? More authority than Stephen Hawking, okay? And so here's another couple evidence proof so that we can convince you, do a little religion here, okay? Persuade you, recruit you. Zero dimension. Leonard showed, and he wrote a paper, this guy Leonard, showed that black hole radius is 0. I mean, how much how much more proof do you want than that? He showed in his paper, and when he was published, right, that a black hole's radius is 0. Okay, scientists now refer to an object with 0 volume, but all of its mass as a singularity. That's what a black hole is. So this event horizon that forms allegedly the region of influence of what? Of a singularity, which is infinite density because it has no volume whatsoever. There is no size. And so a lot of people don't understand that. They, especially, I'm sure these girls would not understand that either. They think that it's just very dense. That's all they think about. They say, well, it's very small. It's infinitesimal small, but it's still small. No, it's 0 size, 0 volume. That's what a black hole is. Why would it stop there? Why would it stop at any radius whatsoever? And then, see, it never comes to their mind. They say, I mean, if I have a star that's humongously big, and let's make it even worse. Let's assume that the star turns into a black hole. Let's concede that. And now the black hole begins to swallow other stars, massive stars, just sucks them in. Well, with all that mass going in, they're being crushed out of existence because that's what black hole does, crushes matter out of existence. It just turns structure into mass. In other words, the ghost of mass remains, but the structure goes to heaven or to hell, I don't know. And so you have more and more mass. At some point, the mass is so great that there can't be any structure in there. So there is no structure, there is no size, there is no radius, there is no diameter. Did I miss one? There is no nothing. That's what a black hole is, a nothing. That's only got mass, a mathematical concept. It's like there's no elephant, but the 5 tons are still there. So, you know, he walks into the china shop and hits everything. You don't see anything because there's nothing there, but it's the mass that's doing it. That's what these people are saying. They're dealing with ghosts, with spirits, but they don't realize that they've been so brainwashed, they don't even know what they're saying anymore. Okay? And that's why I like to point this out. Okay, here's the mass circularity. What is mass? Okay, well, if you ask anybody on the street, anybody who took high school, they'll say mass is the quantity of matter. Okay, and a black hole crushes all matter out of existence. So what is a black hole made of? They say it's made of mass. So we have a circular argument. You know, we have black hole is made out of mass. What is mass? Quantity of matter, or a measure of quantity of matter. Okay, that means it's got some matter in there. No, matter. The black hole crushes all matter out of existence. That's what these people are saying. Okay, so the first thing you have to absolutely fight is the issue of how big black hole is. Does it have size at all? And the answer is no. And that's where the fight is. Because once you have won that fight, then a black hole is irrelevant. Totally irrelevant. There is no such thing as a black hole because, assuming we concede it, it just disappeared out of the universe, the concept universe. It became space, became nothing. And the only thing they say, well, it's the mass is still there. Why would it be there if you crushed all matter out of existence and mass is the quantity of matter? That's the idiotic reasoning of a mathematical physicist, mathematician, I'm sorry. And that's not where the nonsense of a black hole stops, okay? Here you have a little turtle. He's going around, okay? He's going around nothing. And you say, well, hold it. What's making him go around? And then you say, well, mass. Well, how does mass do it? I mean, and so they say, well, mass bends space-time, and then the turtle just slides along space-time. That's their argument, okay? But so the issue is that the turtle is going around only because mass weighed down space-time, but mass is a concept, okay? So this is the issue. The issue is that these people are playing with ghosts and spirits. That's how they're doing their so-called physics, their physical interpretations, which is the only thing that concerns physics. The rest is math. We don't care about that. They can put anything they want in their equations. If they're going to cross the line into physics, we want a physical mechanism. Okay? Okay. Here's what these people say. Well, you're not supposed to take the analogy literally of, you know, mass bendingness fishnet. The fishnet, that I just showed, the turtle going around that fishnet. If I can put it back here. The fishnet, you'll see in a second. That fishnet, you're not supposed to take it literally. It's not real. It's not, they just use it as an analogy. Well, if we remove the fishnet, then what is the turtle going around? So we have to put the fishnet if we're going to give a physical interpretation to it. But then they say they have these cartoons like this one here. Understanding gravity, space-time is like a rubber sheet. Massive objects distort the sheet and what? Student, right? They distort it because they're pulled down by what? Good question. And the professor says, oh my God. Space-time is like this set of equations for which any analogy must be an approximation. What does an approximation have to do with an objective mechanism? What they have to explain is the mechanism. And they explain it with a rubber sheet, with the fishnet, with the trampoline, with the canvas. And then they say, oh, but don't take it literally because the canvas is not really there. We just put it in there so that you could understand the mechanism. So they withdraw the canvas, the fishnet. They take it out and say, you're not supposed to take it literally. Well, I just need to explain this. Let me show you what we need, what these people need to explain. This is the tag. This is the $1 million question they have to answer. Okay, this is what we're interested in. Okay, here we have the Earth, and the Earth goes around the sun. Okay, I hope you can see it all there. And they say there's a wall of warp time because they're going to warp time. They're going to treat time as a physical object. Okay, that's what they do. That's what general relativity is about. Warp time. Gravity warps time. Space-time is warped. Time is part of space-time. Time is warped. So we have the Earth going around the sun, and they're saying the sun weighs down the canvas, the fishnet, whatever of space-time. Fine. We can understand the mechanism because there's a wall, right? It's like a roulette, right? The little ball doesn't fly out. Why? Because there's a wall preventing the little ball going around from flying out. That's how simple it is, right? You understand. Everybody understands the roulette. You just look at it and say, okay, I understand the mechanism. But now they're going to remove the roulette and they're going to leave the little ball going around without a roulette. And even worse, they're going to say, well, the wall is made out of warp time. That's part of the wall. And that's what prevents the Earth from flying out of the solar system. And so you say, hold on, are you saying that this concept called time is warped? And that's the physical entity that comes up against the skin of the Earth when the Earth rolls around the sun, its orbit, its revolution. That's why the Earth doesn't fly out of the solar system, because there's a wall of warp time. And their answer is, don't take the analogy so literally. So you judge on your own there. Hey, this is what these people say. Okay, I was going to go into some of the things that this lady said about geodesics. I'm going to have to leave that maybe for next time. Let me just skip over that. You might say, Bill, why are you beating up on these poor ladies? I mean, they're fine ladies, beautiful girls there, you know. Certainly wouldn't mind having them as my daughter-in-laws. I think any parent would be proud of them, for sure. But that's irrelevant in the context of what we're talking about. What are we talking about? We're talking about, you know, these people going out there and talking about nonsense. They're just repeating what they memorized in school. You know, they passed the test because that's what the teacher told them was the answer. They just memorized it, you know, marked the Scantron sheet, letter D, you know, they passed, 100 points, great. And now they just regurgitate. They just say whatever, they just parrot whatever they were taught by rote, the poem that they learned by heart. And that's what they now regurgitate through YouTube. Okay. Now I've got my what is it? My countryman, my countryman, Pope Frankie. You know, Pope Frankie. He said, "Who am I to judge?" That's what he said. A lot of conservatives didn't like that statement. You know, he said it about gays. He said, "Who am I to judge?" And by the way, good old Pope, he was born near where I was born. This is the city of Buenos Aires, and he was born in a place called Flores. There you can see that area there, the barrio. Close to another fellow, which I'm going to be talking about. His name is Juan Maldacena. He's a string theorist. Okay. And me, I was born on the other side of the river. You see that river there, Riachuelo? That's what it's called. I was born where Maradona was born, in a place called Lanús, West Lanús, Lanús Oeste, which stands for West Lanús. And one of the things I have in common with the Pope is that we're both fans of San Lorenzo, which stands for Saint Lawrence. You say, Bill, you traitor! you're a fan of a team that worships a saint? No, it was Father Lawrence, who was a good man. He got all the boys in the region, and he made a team out of them, and eventually became one of the 5 most important teams in Argentina. Anyways, the Pope says, who am I to judge? But I think it's a little too late. I mean, ask Giordano Bruno. He was burned at the stake in 1600 for saying that the universe was, among other things, universe was infinite, and that there were other worlds probably populated. And that was a big problem, because that means that maybe Jesus was not the only begotten Son of God. So they blocked him, as we would say. They blocked good old Giordano. They censored him. They said, Giordano, we're not going to let you talk anymore. We're going to light a match. They burned him alive. Okay, so yeah, what's the problem with these girls? I wouldn't cry for them. Don't cry for me, Argentina. I wouldn't cry for these girls so much, because they're laughing all the way to the bank. That's one issue. And the first girl, Becky, she's got a little group of people that help her out. It's not like she's alone. She's also helped by Oxford and so on. They don't have a problem with her going out there and spreading the gospel of general relativity. And here you have this lady, Dianna, and she's also, she says, these are things that she said in an interview. She said, my production budget comes from PBS. Now I guess she's no longer with PBS. I think since September, she decided to hit it out on her own, because she's doing fine with what she's doing. She doesn't need PBS, or PBS doesn't need her. I don't really know. Okay. If it were just the YouTube money, I would be fine. So she's laughing all the way to the bank. Okay. So don't feel so sorry for them. I have 5 people working with me, a writer, an intern, I'm a fact checker. Okay. They ask her, is there a downside to this job? She says, creepy people online, like Bill Gates. I hope she was not referring to people like me, but she said, personal attacks and negative feedback happen to any woman on the internet. Well, it's not about women. It's not about female. It's not about you being a girl, or lady. Yeah. No, it's about the nonsense that she's spreading. That's what it's about, at least from my point of view. Okay, so if I'm a creep, well, so be it. I'll be a creep, because what she's spreading is nonsense. Okay, and so again, that's why I attack them. I think they're fair game. I don't cry for these girls, because first, they're doing fine, and I compliment them for that. No problem. I have no problem with that at all. I'm just worried about what they're spreading, and they're the new generation. In fact, these 2 girls have the age of my youngest son, Hans. So they're spreading this to the new generations. General relativity. One more generation that's going to hear about Einstein, how he was the greatest, celebrity ever, and how he had all this authority. So this is the problem. So no, don't feel so bad about them. Okay. What these girls are this. They are wolves in sheep's clothing. Okay. They have their pretty faces online, and a lot of people just watch them or stay tuned to them. Why? Because they understand what they're talking about. They know all the things that are behind all these statements that they make. No, they go there. They say, well, I'm going to get my, my dose of science this week. Oh, I'm going to watch Dianna, or I'm going to watch Becky. So they go in, they tune in, they watch these girls. Do they understand anything about what they're talking about? Of course not, because they don't understand it. So how can the other guys understand it? In other words, they don't have a physical interpretation. So what are they understanding about gravity? Especially gravity, right? But light, magnetism, electricity. They don't understand any of the mechanisms All they do is just regurgitate what the equations say and what they tell the people. They can't talk about equations because people would be tuned out immediately. No, they have to tell them, look, this is the physical interpretation. And all the physical interpretations are irrational. Oh, one's worse than the other one. Okay? And so they say, well, it is so. I mean, they could be telling them angels. They could tell the public about spirits. It wouldn't matter anyway. They said, well, Einstein proved that there are angels. Einstein said that it's angels that carry the earth around the sun. They would believe it as well. They would have no problem with that. Okay? Because it comes from Einstein. You're going to question Einstein? So in a way, I'm ashamed of myself, okay, because I treated these girls as nuns, twisted sisters, right? Phryne. Maybe I'm wrong. Maybe there's something else. Maybe they're more like this. They're cheerleaders, Phryne. Is that what it is? Is that what it's all about? Just entertainment? You know, and so, yeah, I do have a problem with them. I think they're fair game when I attack them, and I don't attack them for them making money, doing a business. That's fine. I love them for that, but not the nonsense that they're spreading. That's where I have a problem with them. Okay. Okay, let's go with the questions and comments that people put out there. Okay, here's the first one, and this is a fellow who requested. He's so-called physicist, another mathematician, and he was on this what is it, academia, where I write as well, and he requested that I comment on his paper. He got in touch with me, said, please comment on my paper. I received a note, and I went there and I put my comment. Okay, and so this is who the guy is. It says Paul Calhoun Wasser, okay, author, self-employed at University of Pennsylvania of 1963, and he wrote a paper. This is the paper I didn't analyze it all because there was no need to. I'll explain that in a second. The gravitational acceleration fields of dipolar repeller voids explain the dark matter effects. Well, when I saw dark matter, dark energy, I said, my God, another. And this guy considers himself a dissident. That's what's interesting. He says he's not part of the establishment. He doesn't even realize that. So he said, I've solved the formerly unsolved major problems in physics. These include dark energy, dark matter, the direct C problem, and the antimatter asymmetry problem. Whoa, he solved it all. Present-day physicists have been unable to solve these and other problems in physics because they cannot see outside the box. I said, well, okay, let's see if he can see outside the box, okay? And I just took his first line. That's the first line of his paper. This is all I analyzed. Okay, I want to get there were so many problems with that first line that I had no need to go through the rest of his paper. It said the dipole repeller demonstrates that negative gravity dark energy exists. Oh my God! And so yeah, I had to attack all that. And what did I put in there? Very simple. Okay, I'm just going to go real quick on what I said to him. If I can get this thing in there. Okay, this is what I said. I said, following the party line and spreading gospel of GR. That's what he was doing. I accused him of that. I said, then there's no definition of energy. There's no definition of mass. He doesn't have a definition of exist. How can he say that dark matter or dark energy exists? That he's proven it? And I said, we do not demonstrate in science, because see, that was his statement there. He said, demonstrates that negative gravity dark energy exists. So he had demonstrated energy exists, and by extension, we also had the word mass. So so I just questioned that he had no answers to those questions. He's got to talk about exist before he can talk about what exists out there. He can also say God exists as long as he doesn't define the word exist. Okay, so he has to define the word exist. And so he goes in there and does the following. he went in there and he says, nothing I wrote came from the mathematical establishment. Whoa, party line or religion. Sorry to hear that you don't believe in science. And so it's interesting that he says he's not part of the establishment, mathematical establishment, okay? But when you go to This is like a little part of his biography. Okay, and he says the following. He says, using the principles of and relativistic equations of physics. Physics? You mean mathematical physics? I have discovered the negative relativistic mass neutrinos are dark energy and accelerate our universe away from us. Dark energy is also the likely cause of the dark matter inward acceleration effect on our galaxies. There is a symmetry between negative relativistic mass neutrinos and their corresponding lepton particle, blah, 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 blah. And I like the last line. This has been a lifetime quest spanning 50 years. I think he's in his 80s now. So what did this guy put out there? He put out mathematical physics. He's part of the mathematical establishment. He gets upset that I said that he's part of the mathematical establishment. What did he do? He blocked me. So that was the end of our dialogue. Now they're doing monologues over there, okay? Yeah, people can't take it. But here, one fellow also asked me to comment on his, and he took it a little better. He took it like a man, and he's got a little, he's putting a series of videos online. You can look them up. Proof of Nothing, a confession on a theory of everything, okay? So I think it's 9 videos that he's putting up there. He's got like 2 of them. This was number 1, okay? So I went in there and did comment on that because he's, I think, approaching it from what the mathematical establishment calls philosophy of science or philosophy of physics or whatever you want to call it. No, it's called physics, not philosophy, okay? And that's what I clarified essentially to this fellow, okay? Here's my synthesis of what I told him, okay, essentially. Said, look, philosophers aren't philosophers. All those you people call philosophers, from Plato all the way to Kant, all the way to Wittgenstein and Ayn Rand, whatever you want to call her, none of those were philosophers. That's not a philosopher. Those were religious people. All those people did religion, 150% religion. All they did was opinions. They did beliefs, recommendations on how to live, on how politics should be run, all that stuff. None of that has to do anything with philosophy. Philosophy is something else. We had to redefine, or better yet, for the first time in history, had to define the word philosophy. What's philosophy? Philosophy is explanations of behavior. You have to explain something in science. Philosophy is one of the 2 branches of science, the other one being physics. And what we do in philosophy, I don't do that because I don't do philosophy. What they do in philosophy is explain behavior. You have to explain why Napoleon went to Waterloo. You have to explain maybe why someone puts drugs in his body or whatever. You know, you got to explain something. He talked about proof, and I said proof, truth, verified, evidence, all that stuff. Religion has nothing at all what to do with science, with physics or philosophy. It only has to do with religion. It's in religion where they prove and where they verify, when they have evidence, all that kind of stuff. Because you're trying to persuade the person. That's what all that's for. So we do not do experiments or present evidence. You can do all the experiments you want at home. It doesn't forbid you. It doesn't prevent you from doing an experiment. It's just that you can't introduce it into your dissertation of physics. Physics only deals with an objective mechanism. Now you can introduce that afterwards as part of, I don't know, your closing arguments to try to persuade people and say, look, this might give you an idea why I believe in this. Maybe you should believe in this too. You know, maybe I can convince you. That's fine. It's human to do that. But we have to identify that as part of religion. That has nothing to do with the objective presentation that deals with science, with physics. Okay? Science, rational explanations, 2 branches, physics and philosophy. Physics deals with science of existence. In other words, physics is the science of existence. So there is no such thing as philosophy dealing with existence. There is no such thing as ontology, epistemology, all that garbage that they've been doing for the last 2,000 years. None of that belongs to philosophy or to physics. If you're going to talk about existence, you've crossed the line into physics. If you're going to talk about the existence of a chair, extraterrestrial aliens that came to Earth, you're going to talk about God, you can talk about any of that. But once you do that, if you're not just going to shoot the bull at the water cooler, If you're really going to talk seriously, then you've crossed the line into physics. It's matter that concerns only physics, exclusively. It's the province of physics. And so the words object and exist belong exclusively to physics. They don't belong in philosophy whatsoever. Okay. Okay, so that's essentially what I told them. And for that, let me just briefly show the scientific method, the genuine scientific method. What science? Rational explanations, and it's this is what we call the scientific method. This is a way of explaining a mechanism, physics, to someone else. When you give a dissertation, you have to present the objects, you have to have your definitions, and you have to present or describe the initial scene. That's what we call the hypothesis. Those are the assumptions. You're making those assumptions because you're talking to the jury. The jury wasn't there when the crime was committed. They weren't even on the scene. So you have to draw a picture for them of what you're going to be explaining, what you're going to be basing your theory on. That's what it's all about. And then you move into the theory. What's the theory? Well, as far as physics is concerned, mechanisms and causes, and then you give a interpretation corollary. Okay, your personal interpretation. Okay, so that's the scientific method, and what is included within that is the famous word exist. And the word exist, the theist, which is a religion, all those three are religion. Theist, atheist, and agnostics, all those belong to religion. They have nothing to do with objectiveness or science. Why? Because one guy says, I believe that God exists. The other guy says, I know God does not exist. And the other guy says, well, I don't have proof. I don't know yet. I haven't made up my mind if God exists or not. No, that's not the way it works in science. In science, we have to say, let us assume. It's an assumption. Let us assume that God exists. God can only be a hypothesis, an assumption. Then you can explain whatever you want with that assumption. You can say, well, this is how God made the universe. Let me explain my theory. Okay, fine. But God can only be an assumption. Okay, what does it mean when you say that God exists? Physical presence. He's an object. God had better be an object if he wants to exist. He can't be a concept like love or intelligence. And he's got to have location. Okay? And what is location? Set of distances. Object is that which has shape. And now we can talk intelligently. We know what we're talking about. Okay? Now we can follow the presentation. Okay, another question or comment here. Fellow says, how would you define mathematics on its own? No theories attached. Mathematics is a language. That's all it is. It's a language, a descriptive language. Is mathematics the language of physics? Well, is Chinese the language of physics? Is Greek the language of physics? Are hieroglyphics, Egyptian hieroglyphics, are those the language of physics? Language is language. The issue here is that for physics, you need qualitative terms. And for math, you need quantitative terms. And so math is just a quantitative language. In fact, the way I define it always is say it's a language exclusively of quantitative adverbs. Math only deals with motion. Math never deals with structure, not even in geometry. Geometry is not a structural discipline. Geometry is a dynamic discipline. You say, what are you saying, Bill? Yeah, I got a sphere or a cube, and that's dynamic. That's not what the geometer does. The geometer, what he does is stretches his measuring rod. He unrolls the measuring tape to measure something. After all, geometry is what? The science of measurement. So he's going to measure things, and then he's going to have relations not between the sides of a triangle. He wants to have a relationship between the distances traveled by the measuring tape. And that's why mathematics, geometry, confused dimensions with number lines, and they just call the number lines dimensions, coordinates, or vectors. And that's why they also confused distance traveled with distance and length. See, they talk about length and they talk about distance. It's neither. Length and distance belong exclusively to physics. Distance is simply separation between two objects, and length is the continuous matter from the edges of, the sides of a physical object. That's what distance and length are. And we do not measure anything in physics. We just say the separation between two tables, that's distance. Now, if you're going to measure, if you're going to stretch your measuring tape and count meters or feet or yards or kilometers or miles, now you're doing mathematics. Now you're going to do measurement. Now you're going to talk about units, numbers and units. That's not distance, that's not length, that's distance traveled by the tape, the tip of your measuring tape. And they've never figured that out. That's why they've got all these concepts confused to this day. Okay, another comment someone made here or question says, does the rope model imply anything about an island of stability? What is he talking about? Okay, well, the other day I brought this subject up. If we can find it here. They're all the way at the bottom. We got like 50 of these. And if you look at the way bottom, those in purplish color there, you see elements 104 through 113. 113 being veritasium, which is what this fellow Derek Muller does. Okay, he invented that 113th element, which is the element of truth. Okay, but until from 104 to 112, these are elements. They call them super heavy elements. And so what this person says is, what is this island of stability? Well, it's a predictive sets of isotopes that have longer half-lives, right, than these super heavy elements. That's what he's asking there. Okay, he's asking in relation to that. Okay, and so the rope hypothesis has nothing to do with that. And the first thing you have to remember, all these super heavy elements, they're all radioactive and they go out in very quickly. In other words, they lose their radioactivity very quickly. And I discussed radioactivity under the rope model in the past. Okay. But they lose their radioactivity, and eventually, given enough time, they all decay down to lead, okay, which is element with 83. And so, once they lose their radioactivity, they just end up being lead. And so they have to create these elements, these super heavy elements, artificially. But other than that, these super heavy elements have no importance whatsoever, except to give job to some chemist or physicist out there, mathematics, mathematician, so that he can have something to do. Who cares about these elements if we're not going to do anything with them, because they only last for a very short time, and you can't build a house with them. It's like, oh, it's interesting. We just created this 112th element for a split second, and it vanished. What the hell? What is that all about? Just so that they can put it on the periodic table? That's nonsense. It's just stamp collecting, as Rutherford would have said. Ernest Rutherford. Okay, another comment, question. And a fellow says, changing the definition of rational now, huh? No, I'm not changing the definition, because there's never been a definition of rational. So we had to define this term because there's never been anyone who defined what rational or irrational mean, okay? And so here you have it. If you look up the word rational, it says based on or in accordance with reason or logic. You look up reasons or reasonable, right? Agreeable to reason or sound judgment, logical. You look at logical, reasonable, to be expected. Look up reason, sound judgment, and good sense. Normal or sound powers of the mind, logic, reason, or sound judgment. What have we learned about reason, rational, any of those? Well, I don't know. We haven't learned much. And here, let me put the icing on the cake here for rationality, okay? And this is a Stanford professor, for those of you who know him. He's Leo Susskind. Susskind, I don't know, Susskind I called. Modern science, this is what he said, okay? Modern science is difficult and often counterintuitive. No kidding. Not science, mathematics. Where intuition and common sense failed, they had to create new forms of intuition, mainly through the use of what? Abstract mathematics. When common sense fails, uncommon sense must be created. Human cognition does not operate according to principles of common sense. So, what is rational? Well, why don't you go ask Susskind? He'll tell you what rational is. Says had to invent new forms of rationality because the old ones didn't work. You know, common sense didn't work. They had to get rid of common sense in mathematics. Okay, another common question. You portray to have a clear understanding of the difference between mathematical physics and real corporeal substantial physics, yet you refuse to apply this rationale, I guess he meant, and reasoning to the heliocentric bullshit of the globe cult you defend. Flat earther. In previous videos, you maintained the belief? I don't maintain any beliefs. That water can curve around the ball with a mathematical physics known colloquially as gravity. Okay? Can you follow your own logic to a reasoned conclusion and judge your own beliefs with equal honesty? Okay? This is what this fellow missed. Okay? Let's show what he missed. And unfortunately, I could not prepare well this thing. I'd like to hopefully he gives me a chance to answer it maybe better next time. I'll try to do that. I'll have a little gift ready, but this is what I can do for now. Okay, this was the last moment thing that I did. You have a little particle, okay, and we'll call that an atom, okay. And a particle under rope model means what? It means that this atom is connected to every atom that comprises that sphere. It's a sphere. You know, assume that's a sphere. Okay, two-dimensional sphere or sphere projected onto 2 dimensions. Okay, but think of it as a volume, a sphere. Okay, you have this little particle or this little atom right at the edge of the sphere. Well, if all these atoms are interconnected, that atom is pulled where? Towards the other side of the ball. It's pulled towards the center, because if you have particles like this all around the sphere, they're all pulled towards the center. And that's what happens exactly to water, okay? And here, let me show you. And again, I wasn't well prepared for this today, but I'll be better prepared next time for sure, okay? I promise. Okay, here you have, okay, one man, and he's being pulled towards the center of the earth. Why? Because every atom in his body, I didn't draw them all, by the way, is physically attached to every atom on earth. They're all connected by the electromagnetic rope, which is the mechanism we propose, the mediator we propose, okay? And so what happens when we have, let's see if I can get this. What happens if we have many people? We have Chinese, we have Russians, we have Africans, we have South Americans, North Americans. Well, here you have them, and they're all being pulled towards the center of the earth. Why? Because every atom in their body is attached to every atom on earth, including the guy on the opposite side. So all these people are connected to each other through the earth. Okay, let's make sure we understand that. That's the model we're proposing. We're proposing that all atoms in the universe are physically interconnected. Okay, now if you assume that those guys are, instead of people, you have water or you have air surrounding the earth, now you see why air doesn't leave the earth, why it covers the earth as a shell, or as a it covers the earth. I mean, the reason we breathe is that there's air covering the globe. And you say, why the globe? Because every atom of oxygen, let's assume it's just pure oxygen, every atom of oxygen is pulled towards the center of the earth, because every atom of oxygen, which is made up of several hydrogen atoms which have been compressed inside stars, okay? Every atom is connected, physically connected to every atom on earth. Every atom in your body is connected to every atom in my body, right through the center of the earth. I'm in Germany, maybe you're in the US, right through the earth, some place in the crust of the earth, every atom in your body is connected to every atom in my body. Okay? So, and I don't pull on you. The atoms don't pull on others. It's just that you have so many of them that the closer you get to the center of the earth, the more you have acceleration. And again, I've explained that in the past. Maybe I'll clarify that a little better next time. I'll give you a better answer to your question, okay? It deserves an answer. I just couldn't get to it on time. It's the only one I had to leave out, sorry. Okay, final issue here so that we don't keep everybody out there guessing. And probably people have better things to do like drink beer and listen to Bill Gates. Gravity is a mystery because there is nothing interacting with anything else, but still it does the pulling. An electromagnetic wave is waving through what? The problems they have today, like you imply, is that QM, quantum mechanics, is just a bunch of mathematics. The math works, but can't be visualized, okay? Yeah, and so what we do in under the rope model, yes, we can visualize gravity. And the reason we can visualize gravity is because, and we can make a movie of it, we can show you the mechanism, is that every atom is physically interconnected to all other atoms. And so here you have a little picture of how gravity works. If all atoms are physically interconnected by electromagnetic ropes, a twined pair of threads, DNA-like mediator, agent, secret agent, right? Can't touch it, can't see it. Then what happens? The astronaut falls to Earth. Why? Because as he falls, all the ropes in his body, which are connected to every atom on Earth, they fan out. Okay, it's not that they're pulling. There's no pull. It's tension. It's tension at every location as the astronaut gets closer and closer to the center of the Earth. He gets closer and closer simply because the ropes, as he occupies different locations, fan out. Okay, so we do have a mechanism for gravity. We do have a physical interpretation for gravity as well as for light, magnetism, electricity, and the workings of the atom. Okay, and with that, I'll see you on Wednesday. Okay.